How are climate scientists able to determine what effects could occur from climate change? Do we know how much carbon could be emitted throughout the 21st century? How does this change if we adapt new technology or introduce legislation to curb carbon emissions? Today, we are going to examine climate change scenarios and what effects we might be able to expect for the remainder of the 21st century. My name is David, and welcome to Explore Forestry. Climate change, as we've discussed before, occurs because of large amounts of carbon being emitted by human processes. This increases carbon in the atmosphere and has the effect of raising temperatures, which then incur many secondary and tertiary effects. But does anyone have an idea of how much temperatures could rise? One thing climate scientists use are called representative concentration pathways, or RCPs. These are a collection of data sets that are used for modeling climate change for the remainder of the 21st century. While there are many RCPs these days, the original 4 are the most commonly used for modeling. Each of them holds different data sets for land use, greenhouse gas emissions, changes in efficient technological adaptation over time, and lastly, socioeconomic and political responses to climate change. There are 4 original RCPs. They are RCP 2.6, RCP 4.5, RCP 6, and RCP 8.5. The numerical portion of the RCPs signify the watts per square meter of warming across the planet, meaning that the higher the RCP number, the more temperature will rise, resulting in more drastic climate change effects. These 4 RCP datasets were used for the Intergovernmental Panel on Climate Change's 5th Assessment Report. The way these datasets work is through climate modeling. Many different climate models exist and can either be localized to a specific region or have a wider, more global range. Climate models are very complex and deserve their own video to delve into the mechanics behind some of them. But for now, let's just say that climate models integrate the raw data from RCPs as well as from empirical studies and combine them into a specific equation to determine effects. For example, models could be used to measure sea level rise under different amounts of warming from carbon emissions. Under a low emission scenario, like RCP 2.6, there may only be a few feet of sea level rise, while under another scenario, like RCP 8.5, there could be a much higher amount of sea level rise. So RCPs provide us different ways of predicting future effects. Now that we know a little bit about RCPs in general, let's discuss each of the 4 main ones to get a sense of the different possible outcomes for climate change. RCP 2.6 represents the best case scenario for reducing climate impacts. Under this scenario, global carbon emissions peak in the 2020s and decline for the remainder of the century. The human population peaks at 9 billion around the year 2050, and use of fossil fuels may increase, but is diverted by increased emphasis on carbon sequestration technology and techniques. Lastly, forest vegetation will still decrease while grasslands increase under an RCP 2.6 scenario. Due to the huge shift in politics, global economic systems, and social relationship to natural resources such as oil, this is considered by many experts to be the least likely scenario. RCP 4.5 represents a stabilization of greenhouse gas concentrations and a substantial reduction of carbon emissions before 2100. Land use changes of RCP 4.5 include a higher percentage of forest due to reforestation efforts and a reduction of cropland and grassland. The Intergovernmental Panel on Climate Change rates this RCP as an intermediary scenario and estimates that this scenario will lead to a rise in temperatures between 1.7 and 3.2 degrees Celsius by year 2100. RCP 6 represents a scenario where carbon emissions multiply until 2060, where they then decline steadily but never reach a level lower than our current emissions. By 2100, atmospheric carbon reaches 620 parts per million, almost 200 parts per million higher than our levels today. Cropland and grassland are still reduced due to reforestation efforts, but oil consumption remains high and other fuel sources are not readily adopted. RCP 8.5 is representative of heavily increased greenhouse gas emissions. Although emissions are curbed over time, greenhouse gases continue to accumulate in this scenario. RCP 8.5 also represents high energy use due to a high rate of population growth and slow development of new and efficient technologies. This rise in population growth also leads to an increase in cropland and grasslands. This is the most extreme scenario and signifies a global temperature rise of 3.2 to 5.4 degrees Celsius. Now, backtracking a little, RCPs are not the only climate change scenarios. The Intergovernmental Panel on Climate Change's Special Report on Emission Scenarios developed 6 potential future scenarios for greenhouse gas emissions and land use changes. Unlike RCPs, these scenarios, called SRES scenarios, do not factor in current or future political actions to reduce emissions. SRES scenarios are grouped into 4 families based on common themes. First are A1 scenarios, with the theme of global integration. These are characterized by rapid economic growth, a global population that reaches 9 billion by 2050 and then declines, quick adoption of new and efficient technology, and globalized cultural and social interactions. A1 scenarios have subsets based on their fossil fuel use or reduction. An A1FI scenario, for A1 fossil fuel intensive, has an increased emphasis on fossil fuel use. An A1B scenario has a balance between fossil fuel and non-fossil fuel energy sources. An A1T scenario has an emphasis on non-fossil fuel sources. Next are the A2 scenarios, with a theme of regional independence. These are characterized by independently operating and self-reliant nations, a continuously increasing population, regionally oriented economic development, and high greenhouse gas emissions. Next are our B1 scenarios, with a theme of global environmentalism. These are characterized by rapid economic growth focused on service and information sectors, a global population that reaches 9 billion by 2050 and then declines, introduction of efficient and clean technology, and global adoption of sustainability goals. Lastly, we have B2 scenarios with the theme of regional environmentalism. These are characterized by an increasing population but at a slower rate than A2 scenarios, regional adaptation of sustainability goals, intermediary economic development, and a slower, more fragmented technological adoption than A1 and B1 scenarios. Both representative concentration pathways and the SRES scenarios are widely used by climate scientists to interpret data and provide a sense of what climates will look like in the future. It is likely that as we move forward through the 21st century, more scenarios will be developed. New technologies advancing from fossil fuel use and adaptation of those technologies will play a key role in how we predict the climates of the future. So will population growth, economic stability, and the way that land is developed over the next 75 to 80 years. In truth, these scenarios not only assist in showing us what could be, but in illustrating the severity of human actions and the need to adopt a more environmentally conscious way of relating to the world. I hope that this video has helped you understand why some environmental reports give a range of effects instead of being able to precisely determine exactly what will happen. There are too many variables to know explicitly what the future holds, but now we can see what the important factors are. As always, thank you for watching, and please let me know if you have any thoughts or questions in the comments below. Thank you for watching. If you enjoyed this video, consider subscribing to our Explore Forestry YouTube channel to receive updates when new videos are posted. Please also consider joining our Patreon so we may continue to bring you more videos like this. Patreon members are listed on each video, and other benefits can be found for the various tiers available. Lastly, be sure to follow us on Facebook and Instagram for more updates. We appreciate your support and keep on exploring.